school. If someone had done that to me, I don't think you would have seen me there. You know what I mean? Like, so the president of this college, the black fellow, he was the first like Democrat effectively that was, or person that Democrat appointed in the last few years. There's been like all Republican people. And the first thing that one of the first things which I was surprised to see when he came in was what he said is that you cannot make the classes about attendance anymore. It has to be about the grades. And if the kid gets the grades on the tests, then they move on. And I think that's the way it should be. You know what I mean? Now, the only problem is all the online testing and all this fake stuff that's going on or whatever. But that's a different issue, you know?
I mean, also, it should be fun.
To some extent, I mean, listen, let me say to you though that like, okay, you didn't come, right? Probably gonna mess up your grade. You know what I mean? Because you're gonna do not so well on the exam. So there's like both sides to the coin. One side is that I sit here and I don't force the person to come, so they end up doing poorly. The other side is I don't force the person to come, so they get to make their own choice. You know what I mean? Both things are important.
Yeah.
There has to be like some trade-off here somewhere.
Yeah.
So I'm not saying what I do is right, but I am saying that I would have killed my teachers if they didn't graduate me because I didn't show up to class one time.
Man, at that point,
Like if you can do this stuff on the test, I don't see what the problem is. Now, I'm not to some degree, but now, you know, whatever. All right. So it looks like we did D5 already.
Yeah.
So we're on E, right? Is this already marked up? It is, because I'm an idiot. We copy again. Now, the thing I like about these two sections, D and E, is they are fairly closely related. The thing I think students don't like about D and E is they are fairly closely related. Because if you don't get the first part, then this is a little difficult. Of course, if you were having difficulty with the first part, the counting, and now you start doing this, this will also give you more practice with the counting stuff. So, I mean, all math is practice at the end of the day anyway. So, did I just copy the wrong one? E2, E1, E3, good. This one actually is blank. Interesting. All right. Blank, blank, blank. Okay. All right, there we go. Yep. I don't know. You gotta check online. I doubt it. I can't imagine that I made a test due today.
The next test is. Yeah. 12-9. Yeah. 4-9. The next one.
Next week, month from last week, same thing, same thing. 7 days, 27 days, whatever. So all right. Does anybody know what probability means? Chance of something happening. Can you describe like a probability to me that you can think of? Like the probability of this is, if a fair coin, you flip a coin, the probability of getting heads, we would assume is like 1/2, right? That's correct. Why is it 1/2? The two things that could happen are equally likely, right? And the heads is one of those two things. So we start saying 1 out of 2. Does that make sense? Right? Can you think of another one? Well, you can't say rolling a die.
What's that? Well, the probability of
Getting a 6 on a die, something like that, right? Because if I roll a die, I mean, there's not really any probability that I roll the die. Anyone, like that's, I guess, 100%, right? If I did it. So then but it's not random then, right? It's random what you get when you roll the die. So the probability of rolling a 6, you said, would be what? 1/6, because there's 6 equally likely outcomes, and then one of those is favorable, getting the 6. Is that correct? Right? All right, so there's some words they're going to describe here. So probability, we already talked about what that means a little bit, right? The probability is really the chance or likelihood that some event occurs. Is that correct? So he says an observation or measurement of a random phenomenon is called an experiment. The possible results of the experiment are called outcomes, and the set of all possible outcomes is called the sample space. So there's something that we refer to as the sample space. And then there's all these events that are in here, or outcomes. Some of these outcomes we would say are favorable to something, to some event that we're looking at. Does that make sense? If each of these things is equally likely, then all I would do is count the number of times these yellow things happen and divide by the total number of things that are in here. Does that make sense? So one of the main things is, can you construct the sample space? Can you write out what the sample space is? Because if you can, then it should be a fairly easy question. Is that right? Sometimes it's hard to do that. And then sometimes there's too many things to write out in there. So then we want to know if there's better ways to do it. Does that make sense? The possible results in the experiment are called outcomes. The set of all possible outcomes is called the sample space. Usually we are interested in some particular collection of possible outcomes. Any such subset of the sample space is called an event. Outcomes that belong to the event are called favorable outcomes or successes. Does that make sense? We say there's like an event, and we say there's some things that are favorable that are in the sample space, and then we say there's some things that are unfavorable that are in the sample space. We take the number of favorable things and then divide it by however many total equally likely events there are in the sample space. Does that make sense? Question? You all right? So then, right? Probability. We just started this one. This one's not that easy, actually. All right, so the problems they give you, they're not so bad, but this can get very confusing very fast. Okay, like very fast. All right. So, if all of the outcomes in a sample space S are equally likely, and E is an event within that sample space, then the theoretical probability of an event E is given by the following formula. The number of events favorable to E divided by the number of events in the entire sample space. Does that make sense? Count how many times E can happen, right? Divide that by the number of ways that anything could happen. Does that make sense? So I really just think about this a lot like the formulas we've been writing the whole time. It's just number divided by total. Does that make sense? We've done that a few times, right? That's how we do percentage. Is that right? Same thing. Does that make sense? So he says shorthandedly, the probability of winning is the number of ways to win divided by the number of ways to play. Well, it's really take the number of ways you can win divided by the total number of ways that anything could happen. Does that make sense? Does that make sense? I mean, we could consider that maybe you're not even allowed to play the game for some reason, but there's a bunch of times when you're not allowed to play the game, but then you wouldn't be able to win then either, right? So if there was a game and then sometimes I play and I win or I lose, and then sometimes I'm not even allowed to play for some reason, maybe I don't have enough money or to play or something, right? Then what she just said here really doesn't make any sense, but I do understand what she means, right? Does that make sense, guys? All right, so consider rolling a fair. Oh, this stuff drives me nuts. A fair die one time, not a fair dice. You roll a fair dice, right? You roll fair dice, multiple dice is plural. Does that make sense? So consider rolling a fair die one time. What is the probability of rolling a 2? 1/6, because we can just write out the entire sample space here. The outcomes we could get are 1, 2, 3, 4, 5, or 6, right? So then this event would be favorable in this case. So therefore we say the probability of rolling a 2, always do the total first, determine the total number of ways that anything could happen. So there's 6 total ways here. Is that right? Once you know what the total is, then out of those total ways, start figuring out which of the parts that are favorable. So in this case, there's 1 favorable event, so we get 1/6. Does that make sense? End up with a 2. Well, so we're saying 2 in this case, right? So what is favorable to getting a 2, right? If I get a 1, it's not favorable. If I get 4, it's not favorable. 5, that's not favorable. 6, that's not favorable. 3, that's not favorable. 2 is favorable, because otherwise I'm not getting a 2. There's one way it could happen out of the 6 total possibilities. Yep. Yep. They could. So like you could say that this is, so I want you to be able to write it like this. I want you to be able to write it like this. Does that make sense? Yep, you just divide it out, right? And then I want you to also be able to write it like that. Okay? Yeah, they could ask any of those. Does that make sense? You understand? Just like before, we talked about this before. Is that correct? All right, so what's the chances we would roll an even number then? 1/2 is correct. The probability that it would end up being even would be, I guess, 3 out of 6 would be favorable, right? This guy's favorable, that guy's favorable, that guy's favorable now. Is that correct? So 3 of them are favorable out of 6. This needs to be simplified though. Does that understand? 3 goes into both of them. Is that correct? Divide the top by 3 and the bottom by 3, you would get 1 and 2. Therefore, we say 1/2. Yep.
Like 3 or 4 wrong, but the rest are right. And I was annoying, and then I realized I was in school. So I bought my laptop just in case, and it's not gonna close out on me, right?
Depends on when it was due. It says, it tells you the due date on there. I don't know I don't know which assignment you're talking about. So you have to look at the due date on the laptop. Oh, you mean like it's gonna, I mean, it'll submit the assignment when the due date comes, but their due date should be it should be tonight or something. All right?
No, I'm talking about like it's gonna like cancel itself out with it.
No, as long as you put submit, then it keeps the question for later.
Oh no, I didn't put submit. I put let me see.
Yeah, so go put submit then. All right, so then this thing, you'll get 1/2.
Oh, put submit then.
Don't submit the whole assignment, just submit the question. It saves the question. You push save and it saves your answers.
Oh,
You don't need to?
No, it doesn't automatically.
Oh, so there you go. So they said it doesn't automatically. Don't worry about it. Rolling a number, okay. Rolling a number larger than 2. What would you say here? You see those checks next to the other ones? It's already done. It's good. rolling a number, because that means it's already giving you credit for those questions.
Right.
So that means you already got the points. So rolling a number larger than 2. Be careful. Now, this is a place where everybody will make a mistake at some point, but the English here, you're making a mistake with the reading. What's favorable to saying larger than 2? So what would that be? Oh, maybe I'm an idiot and I just can't count. Sorry, larger than 2 should be 4 out of 6 is correct. I just can't count. 1, 2, 3, 4. So then this divide by 2, you get 2 out of 3. I guess I'm still on spring break. All right, so the question with that one, other than me being an idiot. Good. Some reason I was thinking larger than 3. I don't know why. All right, considering flipping a fair coin, what's the probability of getting heads? 50% or 1/2 is correct. So then probability of heads would be 1 out of 2. Is that right? Consider drawing a card from a standard deck of cards. What's the probability of drawing a king? Okay, but that can be simplified. And you can think about it simpler, right? So the probability of getting a king, you're right though, is 4 out of 52, but you must simplify this, okay? 4 goes into 52 13 times because king is one of the 13 cards you can get. Is that right? Does that make sense? Right? Because it goes ace through king, right? Ace is 1, 2, 3, 4, 5, whatever, up till 10, then jack, queen, king, so that's 13. Oh, yeah.
Yeah, so you should know this.
Yeah, unfortunately. So the question with this so far, drawing a heart always starts off that way, right? 13 out of 52, but that can be simplified. What is it? 1/4 is correct. Why would it be 1/4? Because there's diamonds, clubs, hearts, and spades. Is that right? It's one of the 4 suits. Is that right? It should be 1 out of 4. All right, now I'm going to remind you that we looked at this deck thing before, I believe. Is that correct? So, like, I really feel like, so I remember doing this like a lot when I was in middle school, this stuff. Okay. And I really feel like I didn't really understand fractions properly until they made me do this. Does that understand what I'm saying? Okay. And it was because of this idea. Like I got it beforehand, but like we never like did anything with it. So like I never remembered or I got confused or stuff like that or whatever. So like when you say hearts and you just said it was 13 out of 52, what the hell? What is this?
Yeah, I don't remember.
Second?
My mom told me that she don't remember.
She's gonna be on the Zoom? What do you mean?
Yeah. No idea what you
So the this thing, 13 out of 52, right? You could either count all of these guys and divide by however many there are here, right? Or we could think about it as just these 4, and it's just that 1 out of the 4. Is that correct? Like 1 row out of the 4 rows. Does that make sense what I'm saying? Right? And that's the same thing as just doing that. Is that correct? Right? Does that make sense? So I don't know, like I felt like this actually helped me a lot with fractions. Does that make sense? All right? Question? Because now you're seeing a use for the fractions a little bit, right? All right, so what would the probability be of drawing a face card? What'd you say? Okay, but how does that simplify? Ace is not a face card. 4 kings, 4 queens, 4 jacks,
For each, there's
4.
face cards.
There's 3 face cards for each suit. That's correct. 3 face cards for each suit. It's 12, right? So how does it simplify? I'm telling you, you don't simplify it. They're gonna mark it wrong. 3/13. Now, again, if you just think about it the way I'm saying it, you don't even need to simplify it. You should be able to tell me that there's 13 different types of cards. 3 of those are face cards. Is that right? It's 3 columns out of the 13 columns. Is that correct? Or don't tell me that this is too hard for you. 12 out of 52. Let's simplify it. It's going to be so hard, right? What number goes into both of those? For sure. Might as well do 2 if you get confused. Does that make sense? Right? 4 goes in there also, but why don't we just do 2? Does that make sense? So 2. So how many times 2 go into 12? 6 times. How many times does 2 go into 52? 2 goes into 50 25 times, so it'd have to be 26. Is that correct? Right? Or you could think of it as like there's 2, like the black cards are half the deck, the red cards are half the deck, so there'd be 26 of those. Is that correct? Right? Just keep thinking about the picture in your head and then it'll make more sense. You understand what I'm saying? So then you get this 26. Now what could I do? Well, I guess we could just cancel again by 2. Is that correct? Right? How many times 2 go into this one? How many times 2 go into this one? And that's it. We get the answer. Does that make sense? It doesn't matter. You have to determine the largest number that goes into this. I mean, it's true. 4 goes into both of these. Great. You divide by 4, you get 3. You divide by 4, you get 13. It is true. It's slightly easier. But what if I don't notice the biggest number that goes in? Fine. Make all the numbers smaller. Then it'll be easier to figure out the next one that goes in. Does that make sense? Any question? I don't know which one's due tonight, honestly. Then yeah, this one. All right. The honestly, this one you don't even need me to do anything. There's not much in this section. Does that make sense? Wait, D1 you said is due tonight? Oh, so this is E1. So this ain't due tonight. Yep.
Yeah,
Really 2 classes ago, but yeah.
we're not having the geometry, or we're going to geometry.
No.
You know, so why are you sending me send us the links to the geometry?
So you watch the videos and I think twice.
How we gonna?
The videos go through everything. And I said we didn't have enough time in class to do the whole unit, so that was the problem. So he was gonna have to rush through it in here and then post the videos online and then have you do it that way, or I just said, why don't you just watch the videos? I think it's simpler that way. And because I find that people get upset when I rush through it. Like they just get more confused, and I don't think it's worth it. You know what I mean? So the last couple of times I've been doing it, people have been telling me it's easier if they just watch the video for that section. Plus also I find that section to be the easiest part of the whole class. Well, of course, but like, you know, there's also some things that we go over in the class here that are going to be on the tests that maybe are, you know, maybe it's hard to think about sometimes. So that's why I feel like otherwise I wouldn't go through any of this. If I assume that you could just read the example and then go and do it, what do I need to go through this for? You know what I mean? But that's not the way it works. Like if we go over it, then you go and look at the example and do it, you'll tell me it's probably pretty easy. Okay. If we don't go over it and then you tell me you look at the example, sometimes you'll tell me you'll get it. Sometimes you'll tell me you won't be able to do it. Does that make sense? Because some of these things are confusing. It's just the way it is. Yep. Honestly, everything in school. They wouldn't make you do it if it wasn't somebody didn't get confused, right? Drawing a king from a standard deck of 52 cards. 1 out of 13. Any question? It's all easy when we do it together. Two fair coins are tossed, say a dime and a quarter. The two possible outcomes for a single coin are heads and tails. Give the sample space. All the possible events. All the possible outcomes that could happen. What'd you say? Nope, that's correct. So let's say I put, let's say I use lowercase h and lowercase t for the dime, and then I use capital H and capital T for the quarter. Does that make sense? So then I could get, for the sample space, lowercase h, capital H. I could get lowercase h, capital T. I could get lowercase t, capital H, lowercase t, capital T. Does that make sense? There's four possible events. Is that right? Any question? What's the probability of heads on the dime? What do they say? 1/2. I mean, if they say heads on the dime, then the other thing doesn't make any difference. Is that correct? Also, you can see here that even if you just do it with this chart right here, heads on the dime, it's 2 out of 4 or 1/2. Is that correct? But you should be able to tell me that doesn't even matter about the quarter in this case, because they're only asking about the dime. Is that right? Does that make sense? What's the probability of heads on the quarter? Also 1/2. Now it's this one and this one. Is that right? What's the probability of getting heads on both? Nope.
One.
1/4.
Right.
How many of these things are getting 2 heads? Just this one. Is that correct? Well, it's 1 out of 4. Is that right? We wrote out the whole sample space. Just count the number of things that are favorable and divide by the total number of events. Does that make sense? Right? You're not thinking about it in the order though that I told you already. All right? Always do total first. Does that make sense? If I say in this case right here, you should be telling me there's a 4 on the bottom first. Does that make sense? Once you determine there's a 4 on the bottom, there's no way you're not going to figure out that there's one way that you can get heads on both. Does that make sense? You understand? The probability of getting the same outcome on both coins, what would that be? Sorry? That one's 1/2. We would get 2 out of 4, and then we would get 1 out of 2. Because this would mean now this one is favorable and this one is favorable. Those have the same outcome on both coins. So we get 2 out of 4. That can be simplified. We get 1 out of 2. Is that correct? 50% of the time you get the same outcome. Is that right? So people always look at me and they're like, oh, you know, that's crazy. You got 2 girls. No, it's not. Like a 25% chance you get 2 girls. Is that right? That's crazy that both of your kids are the same gender. No, actually, that happens 50% of the time. Do you understand what I'm saying? These things are not intuitive. These are not things that our brain can understand very easily. Does that make sense what I'm saying? Once you do these problems and you learn what this stuff is, then your brain can process it. But I'm telling you right now, if there's one thing, I've seen a lot of things in math that are confusing and weird and annoying and whatever, right? But there's not too many things that I sit there and I'm like, nope, you won't figure it out.
So,
This stuff, you won't figure it out unless someone teaches it to you. Okay? And then once you get taught it, then all of a sudden, eventually after you do some of these questions, you turn around and you're like, it's easy. But it's not easy. Okay? So this stuff is not intuitive. You have to build intuition for this type of topic. Does everybody understand what I'm saying? None of our brains work well with this thing. All right. I can ask you questions with this stuff, and I swear to God, everybody will get them wrong. And you'll be very confident that you have the correct answer. Everybody will get it wrong. And then we'll go through it, and then you'll be like, I don't believe you, 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 I don't believe you. Oh, I believe you. Oh, I see why I was wrong. Oh, it was stupid. I was saying that beforehand. But then it's like, no, it's not stupid. Not if everybody says it. You understand what I'm saying?
What we,
It's just, it's confusing. It's not something your brain just does normally.
what we the first time?
Well, it won't be the first time any of them got a question. All right. Someone tells you they got a they never got a question wrong in math and they never did math before. So because you learn by getting stuff wrong at this crap. That's how you learn. So outside of math, the words odds and probability are interchanged. However, mathematically, they are related but not the same. Probability is stated as a fraction or percentage between 0 and 1, comparing the number of ways to win to the number of ways to play, or the number of favorable ways to the number of total ways. Odds are given as a sentence comparing the number of ways that are favorable to the number of ways that are unfavorable. All right, so let's talk about this for a second. So let's say I say that there's some event A here, and then this is not A. Does that make sense? Does that make sense? The probability of getting A would be equal to the number of ways that A could happen divided by the number of ways that A could happen plus the number of ways that A could not happen. Does that make sense? Does that make sense? Let's call the number of ways that A could happen. Let's call that little a. And let's say the number of ways that A can happen. Let's call that little b. Does that make sense? Then this is the same thing as just saying A over A plus B. Is that correct?
God, please.
Stop with this nonsense. Does that make sense? Now, if I was going to do the probability of getting not A, what would that be equal to? What's the total first? What's the denominator first? What's the total?
Two,
Nope.
no,
What was the total when I was doing this one? Nope. Which I said was A plus B, right? If A is the number of ways this happens and B is the number of ways this happens, then A plus B is the total. Is that correct? Is that correct? Why was that confusing? All right. What's the total in this case then? We started asking what the chance is that not A happens.
What's the probability that I get this?
Sounds like right now, well, 0.
You will, but
I'm just kidding. All right, so then if there's A many ways that this can happen and B many ways this can happen, what's the total number of ways? A plus B. Where's the hard part here, guys? Hello? If I say there's A many ways this happens, B many ways this happens, I ask you how many ways is the total thing? A plus B. Is that right? Where's the confusing part? I said A. A plus B. All right, live. So then this is that, right? What's the thing that goes on the top then? How many ways are favorable to not A happening? B is correct. If B is the number of ways that this stuff happens here, then there's B many ways for not A to happen. Is that correct?
I'm more class, man.
All right, so then this thing here, A over A plus B, B over A plus B. Does that make sense? Right? That shouldn't be that confusing. Does that make sense? You can think of this as boys and this is not boys. Does that make sense?
Yeah.
Right? So there's A many boys and there's B many not boys. Is that correct? So what's the chance you get a boy? A over A plus B. Is that correct? Yes? Any questions so far?
No question. So, like, the fact that you said you had two brothers, so this randomly, I just don't want What's the probability of me getting twins? You would know that there's a way that you can actually, like,
So the thing is that like, turns out like twins, there's genetic things that can happen. And there's also environmental issues that can happen that can cause people to get twins. Now, this is like medicine stuff that like you have to ask the doctors and all that kind of thing. But like, my brothers were twins, okay? So, yeah, it turns out that like my great grandparents or something or whatever, like they were twins also. So it turns out like once you have one set of twins, you can have more in your family and stuff like that. And then there's things that people take certain chemicals and stuff like that, and this seems to affect things and whatever. But like you can't, like there's a lot of science behind this stuff. So after you look at all the science, then you could take all this information, you can start coming up with probabilities, but you'd have to know things about the individual person. Did your family have twins previously? Did you, all these, whatever these questions that you need to ask.
I was always really serious.
Honestly, you can't do that much science without doing math. Once you get to a certain level in science, once you get a certain level of science, you can't.
You need to know probability.
That's true. So the odds of A or the odds of event A. So if you notice, you'll go to a casino. When they go to a casino, they don't tell you the probability you're going to win. They tell you the odds you're going to win. When people are gambling and they're gambling in the news, on sports and stuff like that, they don't tell them the probability they're going to win. They tell them the odds they're going to win. Okay. So we need to explain what odds means. Does that make sense? So the odds of event A, all that means is the number of ways A happens to the number of ways that A does not happen. So sometimes people also call this a odds ratio.
Wait, so the line, what time?
Means not. This thing means not A.
And so this you could this for me.
I was calling this not A. The number of ways we can do not A is B. Okay. So you're right. I could say that this is the same thing as A to B, or I could say that this is A over B, or sometimes people will say this is A to B. Does that make sense?
Mm-hmm.
Does that make sense? So what would I say? What's the probability of rolling a 2 or a 3 on a die? What's the answer?
That's two.
2 over 6 is correct. So 2 over 6, and then we would get 1 over 3. Is that correct? What's the odds of rolling a 2 or a 3? What did you say? 2 to 4 is correct. 2 to 4. Now the only thing is this can be simplified. Does that make sense? What can be simplified to? 1 to 2 is correct. So we would write that or that is our answer. Does that make sense? But if we write out the sample space here, for each favorable event, there's 2 unfavorable events. Does that make sense? For each, there's a 1 chance you win, there's 2 chances you lose. Is that right? Does that make sense? But that's not your probability. These 2 things are different from each other. Does everybody understand what I'm saying? Yep.
So I'm surviving a really traumatic car accident, and I just want to know because you can actually tell me this. I survived a car crash. I want to know what is the probability of me surviving my car crash?
Depends on the type of car crash. So like I used to be an engineer. Coma, once you're in a coma, there's a very low probability you survive actually. So like the especially if it's 6.5 days, believe it or not. Okay. So there's different types of car accidents. All right. So like I used to be an engineer. We used to look at these types of accidents and then we would say, because you try to make the car so that if the person gets in the accident, they're not going to get as hurt. You know what I mean? So like, this is what they taught me when I was in school. Okay. People always talk about head-on collisions, right? Do you know how fast you gotta be going to die in a head-on collision?
Really few because you're in the city of a car. I was a pedestrian. and-
Wait. How fast do you think you need to go? How fast do you think you need to go for me to start saying you're probably gonna die if you were in a head-on collision?
40, 50.
15 miles an hour.
Yeah, you serious?
You wanna bet?
15 miles an hour.
Let me explain it to you a different way, and then you tell me if you agree or don't agree, okay? Because this is what they would say to me afterwards, right? Because in the physics, when you start doing this, right, and you start talking about what's actually happening here, one of these cars is bigger than the other one. Does that make sense? Right? The one that's bigger, if they're both going the exact same speed, is gonna push the other one, right? So it's sort of like the bigger one is sort of like a wall. Does that make sense what I'm saying? All right? If you sit here and you draw, now I'm talking about a wall, okay? Concrete wall. If you drove 15 miles an hour directly into a wall, because that's what's happening now. That's really what's happening when you're hitting them. If you drive like this and someone hits you on the side, it's bad, but it's not the same thing. The amount of force that's occurring is not like, you're not like blocked by it. Does that make sense what I'm saying? Like this, it's causing you to go the other direction. You're directly opposing that force. So if you're going 15 miles an hour and I'm going 15 miles an hour, that means we're approaching each other at 30 miles an hour, right? Now, if you're going 30 miles an hour into a wall, are you going to die? Yeah, you're going to die. You're going to die twice. No, you're going to die. So the point that I'm trying to make, I can't make the car. I can't make the seatbelt. I can't make these things to prevent you from flying through that windshield. I can't. It's impossible. Okay. If I make that seatbelt too strong, it's going to cut your head off. That's what's going to happen. Okay. So the thing is that you have to make the seatbelt go out a little further. Once you make it go out a little further, the problem is the car compresses the front of the car, the whole front of the car. The engine moves into the back of the car and kills you. There's nothing you can do. People are like, oh, I'll sit there and I'll push on the steering wheel and I'll hold myself back. Yeah, good luck. You just broke both your elbows too. Yeah, you did. Okay. So you ever seen these people with the minivans? Everybody's got these minivans or whatever, right? You know, they stopped making Dodge Caravans a couple of years ago and stuff like that. You know, the old model. But the thing is you know how many people died in those cars? You know why? Because so the minivans typically have that like slanted front, right? And it has that slanted front, and you sit in there in those chairs, right? And then the ones in the back are there, but they slide, right? They slide back and forth and stuff, right?
That's risky.
So when you crash with that car, and then that front part of that car compresses, because again, I'm telling you, there's nothing you can do to stop that from compressing. There's enough force, stupid thing's gonna start compressing, right? Just like if I stand on this desk and you stand on this desk and she stands on the desk, and you all stand on the desk, you'll see the damn desk start bending. Okay? It's just the way it works. You know? Right now, if I stand on this thing, it'll bend a little bit. You can't see how much it's bending maybe, but we can go and measure it. We can see how much it's bending. But the minivan, the engine starts moving backwards a little, breaks the whole front of the car, then starts pushing the steering wheel into you, right? That's one way it happens. The other way it happens, let's say you get hit from behind in a minivan, the front car seat will go directly underneath the steering wheel, and you'll get squashed. Because the engine's too strong, you won't go through the engine. It'll stop you, but you're gonna be injured dramatically. You know what I mean? So yeah, you drive 15 miles an hour, you're dead. You're dead, like dead, okay? And I'm talking about everybody in the cars, dead. Head-on collision. Now, most of the time, luckily, it's not a full head-on collision. Like the chances that you get in a full head-on collision is pretty slim, believe it or not, thankfully. Because what needs to happen then is that someone has to drive through the red light in the wrong lane. You know what I mean? Like that's like, even if they come from the other lane and they come at you like this, they're gonna bounce off you and go that way. That's not head on, true head on. Does that make sense what I'm saying? Right? But true head on, yeah, you think about it like a wall. That's that analogy works perfectly in physics, believe it or not. Or I can show you the equations and whatever, and it'll make sense. But if you think about even just running 30 miles an hour into a wall, like God only knows what happens then. You know what I mean? Like you're not doing too well at that point. So anyway, I'm just saying it doesn't take that much for a car accident to be very significant. It really depends on the way the car accident ends up happening, what car you were in, were you wearing a seatbelt, which seat were you sitting in, which side of the car got hit, where you were sitting, not where you were sitting. It goes on and on and on and on with this stuff. And the details need to be described. Once you start describing the details, then we can start saying some of these things. But the minute you tell me somebody was in a coma, that means there was significant damage to that person's body. That means there was enough. Here's something else that I learned. Here's something else that I learned, that like most of the time when you talk about like someone dying from one of these things, it turns out that the reason why people die is not actually, I mean, it is, but the amount of force that's felt on the person is not necessarily the thing that they look at to start saying when the person's actually going to really pass away. Okay. What they start talking about is there's fluid inside your body everywhere, water, whatever, right? I don't know if you know this, but if you push on water, like you heard of these things, hydraulic lift or whatever they say, right? Like it's on a forklift, you push the button on the forklift, the thing goes up, right? How does that work? Well, it actually works with something very similar to water. Okay, they put this fluid in there, and then what happens is that if I push on the fluid, water can't be compressed. You can't squish it. When you start pushing on water, it starts going out the sides. Does that make sense? You cannot push it. Okay, that's not true of all liquids. All right, there are liquids that can be compressed. Water is incompressible. All right, so they put the water in this hydraulic thing, and then they push on it, and that's what gets it to move up. Okay, well, you have that same fluid in your body. But now all of a sudden, we're in this car accident, and we are pushing on it. Right? Well, this compresses, right? Because I just felt some force. It's going to push in. Does that make sense? However much it pushes in, the more it's going to push in, right? So this pushes in a little bit, but I'm against the wall. Well, now what happens? Starts pushing everywhere else, right? So they call this viscous flow or something like that, all right? And there's a certain amount of force that can be applied to your body before the viscous flow in nearby your heart, nearby your brain, and all of this stuff is not too much that it's going to severely damage your heart or brain. Does that make sense? It does not take that much. Okay, that's why you'll see sometimes that these people, one punch and the person's dead. You catch them the right way, it's quite possible. Does that make sense? All right, so this is what I'm saying with this thing. It really depends on all these different things, like which type of impact. Did this happen? Did that happen? Did this happen? Did that happen? And then we can start trying to predict. But honestly, I wouldn't worry about trying to predict how likely it is for you to die or something like that. I'd be just thinking that you're still here. So because all that means is somebody's watching you. So this, and we all would like to have somebody watching us, right? So this thing here, I mean, I've seen some horrendous accidents and people have walked away, and I've seen some horrendous accidents and people have not so horrendous accidents and people have not walked away. You know what I mean? So. No. Thank you for being here. All right. So this thing here, right? Do you understand what I'm saying? Odds versus probability. Probability is like the favorable things out of the total. Odds is the favorable things to the unfavorable things. Does that make sense? You get it? It's easy to think these two are the same, but they're not the same thing. Is that right? Now, probability of some event is going to be less than or equal to the number of total events divided by the number of total events. It's got to be greater than or equal to 0 over the number of total events. The reason being is that the number of events in the sample space there cannot be more favorable events than there are in the sample space. Does that make sense? Maybe everything is favorable, right? Then we would get 1. Is that correct? Or 100%. Is that right? Maybe nothing is favorable. Then we would get 0. Is that right? The probability has to be some number between 0 and 1. Could be 0, could be 1. Does that make sense? Odds don't work like that, though. We just saw that the odds of getting a 2 or a 3 was 1 to 2. Is that right? What would be the odds of not getting a 2 or a 3? The odds of not getting a 2 or a 3 would be 4 to 2 or 2 to 1. This does not have to be between 0 and 1. Does that make sense? Do you understand?
Yeah, one more time.
There's these two words they're using with this stuff, odds and probability. They're very similar, so it's really easy to get confused. Probability means a chance that something happens. So you can get anywhere between 0 and 1, could be 0, could be 1. Odds could be anything from 0 to infinity, though. Odds could be like 5 to 1, right?
I thought odds and probability was
Nope. We just did it. We got 2 different answers. The probability of getting 2 or 3 was 1 out of 3. The odds of getting 2 out of 3 was 1 to 2. Does that make sense? Does that make sense, Justin? Question? Sorry? There's 4 things that are favorable to getting not a 2 or a 3. 1, 4, 5, or 6. Right? The other things in the sample space. Does that make sense? What's the number of ways to get not a 2 or a 3? 4, right? All right, what are the odds in favor of rolling a 3? What would you say?
what was it? Probability of what?
Odds.
Oh,
What'd you say? 1, 2, 5. Don't just say 1, 5. All right. 1, 2, 5. 1 way is favorable to getting a 3. 5 ways are unfavorable to getting a 3. Is that correct? Favorable always comes first because odds of getting what we want, not odds of not getting what we want. Does that make sense? Question? What are the odds against rolling a 3? Does that make sense? Now you could say the favorable event is not getting a 5. Does that make sense? Not getting a 3, excuse me. Sorry. All right, just because we want to just make sure we understand the difference between these things. What's the probability of rolling a 3?
probability is
These are the 2 things we're talking about, yeah. What's the probability of rolling a 3? 1 over 6. What's the probability of not rolling a 3?
No, 5 over 6.
Does that make sense? Anyway, you understand the difference though, right? Any question here?
No,
Yeah, I love it.
yeah, yeah.
How people guess the correct bracket, you mean?
What's the odds?
No, they don't. Like, that's pretty complicated, honestly. So one of the most difficult things to predict in the entire world actually is what happens in this tournament. That's why they give out $1 million if you get it right. No one's ever gotten $1 million. So I've won brackets twice in my life.
For real?
Both in high school when I was doing it. I didn't know. I knew barely anything about college basketball. I just guessed a little bit and got lucky. So some things I knew. but most of it was
So
guessing.
you won twice, man, you know how to dunk, I mean, like.
But I'm telling you, it's still lucky.
You better do it right.
Yeah, I got lucky. But
So what-
but I got second place one time. I got first place the other time. But still, I'm telling you, I got lucky. All right. So the way it works is like you have to look at. So if you look. So everybody will make these predictions all over the place. Like here, the first website I go to, they're telling us these predictions, right? This is one of the best jobs to have in the entire world. You can sit here and be completely wrong, and then you'll be back on TV next year, okay? Because everybody's wrong, all right? First of all, this is not a simple game to play because you're talking about a serious amount of different possibilities that could occur, okay? So just to start saying the possibilities, right? Each of these games has two options. How many games are there? There's 32 games, 16 games, right? Do you know that's 2 to the power of all these things? It's 2 times 2 times 2 times 2. Okay. You know how many different possibilities there are? Billion. Okay. The lottery is easier than this game. Okay. The lottery is easier. So then the thing is that you got to guess all this crap. All right. Now, that's if everything was equally likely. Everything is not equally likely. We know there's some teams that are better than other teams. Okay. So then we start looking at. Honestly, it's a good question. There was a time when I thought where all I would do to teach one of these classes is literally just do this for the whole class. Where all we do is start trying to bet on this and get what the answer. Because I think people will sit there and pay attention more to that. But I didn't have enough. I just haven't. I don't want to spend that much time actually coming up with it, believe it or not. But sorry.
University of Miami, there's no gym.
Honestly, I would think so, but I don't know. Yeah, I don't know. Well, a lot of people are there. I mean, they invite pretty much everybody. But so then if you go look, there's something called RPI. So here's this. This is what people have used for decades or whatever. So so they have all the rankings, right? But then the problem is that so Alabama's in the SEC. Kansas is in.
At 12, I think.
I think they're Big 10 or Big 12. I think they're Big 12 now. But the Gonzaga, it's one of those dumb conferences. I don't remember. It's one of those conferences don't matter except for basketball. But so the Houston, whatever. Anyway, each of these teams that's in a different conference plays different teams. Okay? The teams you play, obviously, you're gonna say how good you're gonna be. Right? RPI is some measure of how good your opponents are. I guess so. I didn't know that, honestly. God, I hope they lose. All right, so then I went there. I hope they lose. So yeah. Honestly, I hate that school. So I've never been to a college in my entire life where I've seen more people fail when they're seniors than that school. Because they just pass them, and they get up to the senior year, and they make the hard classes harder, and now all these people start failing. I don't think that's right to do that. That's waste someone's money. I feel like they're stealing the people's money. You know what I mean? So I hated it. So and I don't know, it was just dumb. But honestly, it's all the schools are the same. It's the same crap. This thing, so like they have all these records, but then we have to look at the strength of schedule. Okay, and then we also have to look at the head-to-head matchups. You have to start sitting here and looking at like, did Duke play Houston? Oh, they did. Who won? Okay. Oh, and then which one of those teams up here also played one of these two teams? Did they win? Right? But then it gets confusing. What if Houston beats San Diego beats Gonzaga, and then Gonzaga beats Houston? Well, they all just beat each other. Now what? You know what I mean? So anyway, so you start sitting there and thinking about this, and then what you can do is you can generate or guess effectively using the computer what could happen. So you start assigning some chances that each team will beat another team. Then based off the chances that they beat another team, you sit there and generate all of the total chances, okay? And then after I generate everything, in other words, I effectively make the sample space, then I start counting how many times Houston made it to the end, how many times this one made it to the end, how many times this one made it to the end. And then you bet based off of that. Does that make sense? The simplest way to do it without doing all this math is to go and look at the predictions that these other people have made, read all their predictions, which takes forever, honestly, because you got to read a bunch of different people's stuff. Then after you read their stuff, start figuring out if the stuff they're saying makes any sense. Then play them off each other. So like use this guy's stuff. He says Houston's going to win because Houston has this one guy. He's amazing. This one says Houston's going to lose because the other team has a great defense. And then decide which one of those is right. And then start going with it. That's the simplest way. That's how I won before. What's up?
Side note. This is kind of off topic, but my birthday's coming up.
Happy birthday.
Thanks.
The odds in favor of drawing a jack? Go ahead.
My birthday's coming up on March 16th. This Thursday.
Mhm.
So, you know what's so cool on my birthday? What's so important on my birthday?
No,
There's two things.
what is it? Well, other than you being born.
Yeah, that's true. Yeah. You really have it?
Yeah.
I will give you something yesterday. Not give it.
You getting a gun on 16th? What?
M16?
Really?
Yeah, M16.
Really?
16. And also, if you want to get Christian, you want to get biblical. I realized this when I was like 7 or 8. My mom told me, read this Bible scripture. And like, after I read it, John 3:16, like, wow. I
Did you ever see wrestling?
yeah. Yeah.
Because what's his name? Steve Austin. He used to say 316.
Well, that's me.
That was us.
What is it?
So, all right, we gotta do this though. We gotta finish this. What are the odds in favor of drawing a jack? 1, 2, 12, right? Okay. You could, if you write this, it's correct, but you're supposed to say 2. Does that make sense? You don't want to say 1 out of 12. That sounds like probability. Is that right? Right? Okay. What are the odds against drawing a jack? What are the odds in favor of drawing a club? No. That's probability. One out of 4 is a probability. Sorry? No, just stop saying this out of nonsense. You're gonna get everything wrong, I swear to God. So like 13 to 39, but again, you don't want to think about it that way. There's one club and there's 3 other ones, right? Heart, diamond, and spade. Does that make sense? So it's 1 to 3. What are the odds against drawing clubs? So that's obviously 3 to 1. And randomly choose a single ball from a can which contains 6 reds, 2 yellows, 3 blues. What are the odds against selecting a red? Five to six. Does that make sense? What are the odds in favor of selecting a blue? No. 3 to 8 is correct. Don't do this. You guys keep messing up the order. All right. Favorable to unfavorable. I want to say the number of things that count for me first. Does that make sense? All right. What are the odds in favor of selecting a red or a yellow? 8 to 3. Does that make sense? Question? Owned? I used to like run this business for this car shipping stuff for these people. But
Yeah, but I need your help with like, I'm trying to start a movie.
let's talk about it afterwards. I'll help you. Compute the probability of event E. If I can help you, I'll help you. Compute the probability of event E if the odds in favor of E are 19-9. What's the probability of getting event E? If the odds of E is 19-9. Very good. Very good. Very good, honestly. That is a question that most people have a lot of difficulty with. So like E, there's 19 ways it could happen. Does that make sense? Not E, there's 9 ways it could happen, or that's the ratio of them. Does that make sense? Right? So then the number of ways that are favorable to E is 19. The number of total ways is 28. Does that make sense? That one's harder, all right? Does that make sense? Good. As noted above, empirical probability is based on actual experiment. The computation of the probability of an event happening is similar. However, we will use the numbers from the experiment as opposed to using the ideas of theoretical counting. If E is an event that may happen when an experiment is performed, then the empirical probability of event E is the following formula. This is so stupid, it's not even funny.
Yeah,
So
I'm sorry, I just had to do a cycle.
the so if we have a coin, right, and we keep flipping the coin over and over and over and over and over again, I mean, there is a chance that we sit here and we flip the coin a billion times and every single time it hits. Is that correct? Not a very good chance.
No,
But there's a chance,
yeah.
right? So what I could do is I could, like, if we kept flipping the coin, we didn't know if it was a fair coin, say, right? We could start saying like, hey, let's count the number of heads we keep getting and divide it by the total. If we do this for a long time and we keep flipping it fairly, right? Should be around 50%. Is that correct? I mean, I don't expect us to get exactly 50%, but I would expect it to be close to 50%. Is that right? Like you flip the coin 1,000 times and I get 501 and then 499 tails, I'll be like, yeah, whatever. Right? But if we flip a coin 1,000 times and you get like 700 heads, I'll be like, yo, your ass is cheating. Seriously. Did I mention this story to you about math competition thing and cheating or whatever? The teacher caught me and stuff.
Yeah.
This is how they catch you. This is the whole idea behind all statistics, believe it or not. We have an idea of what the chances something happens is, and then all of a sudden somebody comes around and I'm like, it happened to me 20 times in a row. And I'm like, wow, you're amazing. That's like the first time that's happened in human history.
So what's the
It's
probability?
such a rare chance that'll happen. Okay, that's not true then. It's not the first time that's happened in human history. The person's a liar. Does that make sense? Do you understand? That's called hypothesis. Question?
So what's the probability of a modified this time?
100%, but we'll tell her right now. Oh, is it? I'm kidding. So the empirical probability. So the whole thing is that empirical probability means that we could sit here and we start calculating the chances that something is going to happen. And as we increase the sample size more and more and more and more, we would expect it to start giving us closer and closer answer to the actual true probability. Does that make sense? Right? Like we don't actually know that there's only 2 events when we flip a coin, heads or tails, right? It's really every single time we flip the coin, it's like, oh, the first time we got heads, second time we got heads, third time we got heads, fourth time we got heads. There's like, it's almost like different heads. Does that make sense? Like you would write all of them down. You'd be like, oh, heads, heads, tails, heads, tails, 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 heads, tails, heads, tails, heads, tails, heads, whatever. And you would just keep writing it all down. Is that correct?
Sometimes you get good heads and sometimes you get bad heads, you know.
You're crazy. So then this boy be crazy. All right. So then the sometimes, so like this thing here, right? This is, start calling it M16. All right. So then this by the way, I should.
Well,
All right, so wait, so we go through this, we start counting all these things up, right? What I could do then is, if I wanted to see what the chances of getting heads, I would count the number of heads and divide by the number that happened total. Is that correct? Right? Or the number in the sample space. And then we could keep doing this, and we could do it more, and we could do it more, and we could do it more, and whatever. If I did it for a longer and longer and longer period of time, then this, we call it relative frequency, or we call it empirical probability. This is an experiment then. Does that make sense? Does that make sense? And then if we, these numbers, if we let n go to infinity, where n, let's say, is the denominator here, does that make sense? In other words, we do this forever. Does that make sense? Right? You do it as much as you possibly could with that coin. You understand? Then this would eventually give us the probability of heads. Does that make sense? Does that make sense, guys? Right? So that's what we mean by probability of heads. It's the, we say it's the long run relative frequency or empirical probability. Empirical just means coming from experimentation. Does that make sense? Or observation.
It goes on to.
You can. But it's harder, but you can. Yeah. So this thing is called the law of large numbers, right? The law of large numbers says that if we repeat some experiment over and over and over and over again, we did it for as long as we possibly could, then the true value of the long run relative frequency would converge to, or eventually become, the value of whatever the true probability is. Does that make sense? Does that make sense? If you flip a coin a bunch of times and you count how many heads you had, then I say you got 40% of the time you got heads, right? And then we flip, I say to you, oh, you didn't flip it enough times. Flip it more times. So you flip it 1,000 times more times. So you flip it like 1,000,000 times or something. Then we count how many heads you have. Take the number of heads, divide by the total. We would expect that this value or number is probably getting close to whatever the true answer is for the probability of getting heads. If you don't like that, do it more times. If you don't like that, do it more times. I'm saying this means you do it as many times as possible. Does that make sense? In a hybrid corn research project, 250 seeds were planted, 195 germinated. Find the empirical probability that any particular seed of this will germinate. This one's pretty easy.
yeah. So who we look at seeds?
What did I say to do first? Always. So what's the total? 250. What's favorable? 195. And that's it. All you gotta do is simplify. Does that make sense? So this is 39 out of 50. So that's the same thing as 78%. Does that make sense? Divide by 5. Does that make sense? Question? A particular disease is tested for, and the results determine that it occurs in 1 out of every 425 Caucasian females and 1 out of every. Oh, here's one I can tell you also. So my mom passed away a few years ago from Thank you. My mom passed away a few years ago from cancer, and she had breast cancer twice. So first time she got breast cancer, they were like, "You're gonna die. You're done. It's over. You have stage 4 cancer. You're definitely gonna die. You're definitely gonna die." That's what they said to her. All right. So that was about, luckily, 7 years before she passed away. All right. So she ended up living for quite a bit of time, thankfully, without that. All right. So then the crazy part though is that she went in there with 4 women that were with her. All right. They were all in the same group. This was in this Cleveland clinic over here, Weston somewhere or something like that. So she goes in there, and I'm telling you the truth. They told her she's gonna die. Honestly, based off of what occurred and what was going on with her, I'm still surprised she lived. Thankful she lived, obviously. But she was living on borrowed time, for real. Okay. So they said she's gonna pass away. The 4 other women with her, they had stage 2 and stage 1 cancer, all breast cancer as well. Okay. They said to them that they had a much more reasonable chance of living. All right. All 4 of the other women ended up passing away. Okay. It turned out the 4 other women were all African American. You're like, so what? That's what I said first. My mom told me the story. I was like, so what? Well, the medication that they had developed for her particular type of disorder, which she had a bad version of breast cancer. There's like something called sex-linked breast cancer, and there's non-sex-linked breast cancer. Sex means sex chromosome, all right? So the female chromosome, somehow it's linked to that chromosome or whatever. When that happens, it turns out it's a worse form of breast cancer. It's harder to get rid of. It usually comes back, which what happened with my mom and stuff like that. But so they gave her these drugs. Now, everybody knows cancer medicine, tough stuff, right? Like it causes a lot of problems for the person. Sometimes people even turn around and sit there and start saying, hey, maybe don't even take the medicine because it's so bad. What's going to happen to you, right? So that was where we were at. We were like, hey, should she even bother? We already said she's going to die, right? Should we go and give her the medication and make it even worse for her before she passes, right? Should she at least be able to enjoy her last few days or something, right? She said, no, I want to fight. I want to do it. So we gave her the medication. Luckily, it worked. All right. Of course, the exact same thing happened 8 years later, and then it went the exact other direction. They gave her the medicine and actually killed her. All right. No, it is what it is. Thank you, though. So the thing is though, those 4 other African American women passed away, and their doctor had told them that they had a much more reasonable chance than my mom. How did my mom live? And they passed away. Okay. So I'm reading this thing, and it starts saying something about Caucasian females here, right? Well, as much as people want to say it, we do have different genetics. Or people want to say we're all the same. We are mostly all the same, honestly. Like the large part of how every bit of every person's body is mostly the exact same thing. Okay. But if I sit there and I stop feeding you, and use generation after generation after generation that has to struggle through having not enough food and not enough whatever, then some things are going to change in those people, right? Right? There's slight differences, whatever these slight differences are, right? So that's part of how your body fights off all these tough things that are occurring and develops and makes you stronger and makes people live longer and all this other stuff, right? Well, the medication that they came up with this cancer drug, it turns out was tested only on white women. Well, it turns out they didn't know how to help the black women anyway at the time. Okay. So as a person who used to do science and stuff like that, it's hard for me to understand how you can come up with a drug for one person and then immediately start saying that's going to work for the next person. It's not going to all the time. We are different from each other,
You're
right?
you're
So sometimes the drug interferes with some of the genetic differences, and then all of a sudden isn't going to be as effective, right? Just like we know that some drugs work for men, some drugs work for women, right? Right?
That's
I mean, they don't even make the same deodorant for men and women. They don't make the same vitamins. They don't make the same all kinds of things. Does that make sense? Right? So anyway, the only reason why I'm bringing this up is because I'm trying to tell you that these statistics and stuff, they are extremely important. They do tell you a lot of information, all right? It is important to be able to read these things so that you have an idea of what's going on. Does that make sense? It wasn't the doctor that told these other women that they were going to be more likely to survive. The doctor did not say that to these African-American women. The African-American women heard what they said to my mother and then assumed that they were more likely to survive. The doctor actually thought that all of them were going to pass away, believe it or not. Because he didn't think that the drug that they gave to my mom was going to work. You get what I'm saying? All right. Anyway, all I'm trying to say is that these statistics are extremely important. I told you the story about the steroids and my kid.
You give me some cancer.
I didn't tell you this. So my kid was sick. He had like 103 fever or something like that. Couldn't sleep.
That's
And I had to like hold him up at night, coughing and all kinds of stuff coming out of his mouth and just couldn't sleep days. It was just going on. Okay. And like, you know, you got 103 fever and I think he was 1. And this type of thing happens when the baby is 1. Like, this is dangerous. All right. These cause brain damage. It can cause all kinds of things, permanent damage. Right. So, and plus I'm not sleeping. I don't know what the hell's going on. You know, I'm worried about the kid. Right. So I take him to the doctor's office. Doctor says you should give him this steroid. She didn't tell me it was a steroid. My wife's like, go get the drugs. Go to Target, get the CVS, get the drugs, right? Hopefully it'll start helping him. I go to Target, start trying to get the drugs, about to pay with my credit card. I was like, hey, by the way, how much is this? They're like, oh, $200. I was like, what? Insurance? They're like, no, $200. I was like, what the shit am I buying? And then I looked at the drug and I was like, blah, 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 blah. It ends with like ONE or whatever. I was like, I remember from my science classes, I was like, that's a steroid. I'm like, oh, so we're giving the kid a steroid. Steroid's $200. Yes, it is. Okay, fine. Well, steroids are kind of strong. I don't know if I should give my kid steroid, you know, right? So, you know, I'm sitting there and waiting. So the woman has to like fix it up or whatever, and, you know, get it ready and stuff like that. So, you know, there's this, they give you the little bottle and it's got that paper attached to it, right? That huge stack of 27 million papers. That's pamphlet thing that's attached to the thing, right? So I start reading the damn thing. So I'm like, I'm paying $200 for this thing. We're gonna give my kid steroids. I was like, I want to know what I'm giving the kid. So, you know, it's got all these words and words and words and words and words and words, and then it shows statistics. Because every single one of these things has to prove to people how well it's actually going to work, right? What's the point of you buying a pregnancy test in the store and then you find out the pregnancy test only works like 40% of the time? Well, I don't want to buy that crap, right? It's not very useful, right? Well, what's the point of getting a flu test and then finding out that the flu test doesn't work so well? You know, like, I might as well not get a flu test. I already know I'm sick anyway. Is that right? Okay, so, but that's not the way these things work. These things are much more effective, right? The pregnancy test does work, right? So so I started reading through this stupid thing. It says on there that if a kid's around the age of 1, they gave it to a bunch of kids that were at this age to see how the effects on the children. And they write in there this thing that they call a confidence interval, right? And what was the confidence interval? Discussing the height change of the kids over the next calendar year. Kind of important for a 1-year-old, right? So what did it say? It said that if you take the steroid, then they expect that the height change that the kid will have will be actually negative compared to most children of that age normally without taking the steroid.
Really?
In other words, they will be shorter. In
Oh,
other words, this will stunt their growth
oh, no, then why would
at a
I?
high rate or high chance. Well, if the kid's gonna die, I'm gonna give it to him,
Oh, yeah, of
right?
course, of
So
course.
but if the kid ain't gonna die,
Give me that.
maybe I'll give it to him one time, and then that's it, right? So they sit there and they tell me give it to him twice a day for a month.
Yesterday. Well, for like 2 months.
I gave it to him like once a day for like 3 days,
Yeah, yeah,
and he started feeling better. I was like, good, I'm done. That's the end of this, right? I don't want him to be shorter for his entire life because he's coughing, right?
Of course.
I mean, I cough too. Does that mean I'm gonna sit there and take juice? I don't think so. So the Sammy Sosa's diet. Anyway, but you probably don't even know who Sammy Sosa is. But the what do you say? No. The way it works, no, your genetics can't make you catch up.
More juice than OJ.
You only have a certain number of growth spurts. You during that growth spurt period, you're supposed to have a growth spurt right now, and you sit there and you don't grow, then you don't grow. That's it. It's over. You don't sit there and make the person grow later and stuff like that, unless you want to go give them HGH or some nonsense. But but my point is that this is what they said. This is what the doctor told me, right? My wife was like, go get the damn drugs. Give him the drugs. Doctor said, give him the drugs, give him the drugs, right? Isn't that what you would do? Right? Doctor sat there and told you that this is what's going to happen. You actually, you were really sick and you went to the doctor and doctor said, prescribed you this stuff. You're going to go take the drugs, right? So oh, I don't know. Yeah, I don't know. When you actually get sick, we'll see. So I hope you don't. I mean, I'm not saying, but the thing is but when people get really sick, things change very quick and you get really scared and you're like, well, you make a decision. You're like, if I'm going to die, maybe I'll take this thing, right? And the doctor will explain to you, this whole situation, right? Make you feel comfortable with it and all that kind of thing. Anyway, so the doctor said this whole thing, right? Now I was like, give him the drugs. I was like, you know what? We're not giving him the drugs, okay? But the thing is I still have it in my refrigerator. I still give it to him every once in a while.
More juice than OJ Simpson.
So then but the thing is that if you don't know these statistics and can't read these things, right? Then you have nothing to do but listen to that doctor or listen to whomever. I talked about this with the investing, right? And I said that you need to eventually be able to invest your money and make decisions about where you're going to put your money, right? How are you going to make these decisions? Either you just turn around and listen to somebody and do what they say, right? Or you figure something else yourself. Is that correct? But you need to be able to figure it out. So anyway, my point with this stuff is that these things that we're talking about help you get in the direction of possibly being able to answer some of these questions. Does that make sense? So that's why I find it important. Okay. All right. A particular disease is tested for the results and determine that it occurs in 1 out of every 425 Caucasian females and in about 1 in every 191,000 non-Caucasian females. Oh, here's another one. Just another story, just to explain another situation why some of these things end up being important. My uncle, so I'm half Jewish, right? People always say that there's like these Jewish diseases and stuff like that. Well,
Do the Holocaust or like?
no, because people wouldn't let the Jews mate with other people. Yeah, nobody would. People.
This is like biblical time. It's like during the Holocaust. Really?
So you go look in countries around the world, like people hate Jewish people. So it's anti everything, but there's a lot of people that hate Jewish people. So like
You're Jewish? I didn't know that.
the half Indian and half Jewish. So I always say that like
That's crazy.
that's what I said. I was like, if you can tell me who I get to be racist to, like who's below me, I would like to try. Like I don't get that chance. You know what I mean? So like Jewish people, like it's every group. You look at Black people, you look at Koreans, you look at Japanese, you look at all these people, any group of people that was forced to breed with itself over and over and over and over again in small groups eventually developed genetic disorders. Does that make sense? You look at the kings and queens of Europe. The king was not allowed to have a baby and be a prince, and the prince then had to marry a queen from another country. Well, guess what? All these people had the same genes eventually. They all started becoming a little, like they were having all kinds of issues and stuff like that. Okay, so this is well known that this type of thing. That's why we don't want people marrying their cousin.
Yeah.
Right, and the sister and all this stuff. Right, this is ridiculous. Okay. No. So like no, I know. So all right. So anyway, so the thing is, I have flat feet. I have some other issues that I've had since I was been born, and my uncle, but I don't have all the issues that my Jewish family has because my mother married an Indian person. So then when there was no other part of the gene to give me anymore. So luckily these things, I might have them in my system, but they don't actually affect me. Does that make sense? But my mom, she was affected by this stuff. My uncle, he was affected by this stuff. Like he had all these terrible, terrible, terrible things happen to him, right? So he couldn't walk by the time he was about 33, something like that. He couldn't play sports when he was a kid, right? And they kept calling him a wimp, and they kept telling him that he's go play and stuff like that. He started throwing up all over the place and whatever, because his muscles couldn't repair themselves and make new muscle. So he would go play baseball outside in the street, and next thing you know, you were playing baseball also, and you get a little tired, and then your muscle, you slow down for a second, and your muscles start repairing yourself, and then you feel better, and then you can go play again. He can't do that. He had something wrong with him. Okay, so they said he had gout. They said he had arthritis. They said he had, I don't remember all the different things anymore. All right, but they said he had about 17 different diseases. All right, it wasn't until the man was something 40-something years old that they figured out he had this disease called Terui's disease. Well, guess what? You want to know the reason why they couldn't figure this out? Because there was only 79 cases of Terui's disease ever diagnosed in the entire world at that time. How the hell is a doctor going to figure this out? They've never even seen it before. How are they going to know that you have it, right? I mean, this is like a needle in a haystack, literally. Does that make sense? All right. But the point is that if you don't understand these statistics with this thing, you can't even understand how to deal with the doctor. Does that make sense? Okay. And you're going to look at it the wrong way. And you're going to say, oh, it's happening because I'm black. It's happening because I'm a Jew. It's happening because of whatever. Maybe. Probably not, honestly. Does that make sense? All right. So I'm just saying, please, if there's one thing that ends up being the thing that you should come out of this class and think that you should learn a little bit about, it's statistics. Does everybody understand what I'm saying? Because if you go into an industry or a job and don't have to do statistics, I'm telling you, you're not making that much money. You're not. Because there's no way anyone is going to put themselves or put someone in place to control lots of things that can't understand how to analyze it. And that's all this is about. Does that make sense? Question?
So we will so me and you, right? Every morning, every day, throughout the whole day, we both start sunbathing.
Sunbathing?
Yeah, so we start sunbathing.
I don't know if you want to see me sunbathe, but okay.
No, you don't have to.
No, I'm kidding.
We sunbathe.
Okay.
What's the probability?
So you want us to get skin cancer?
Yeah, what's the probability you get cancer or me gets?
You got a better chance. You got a better. So the thing is melanin.
It does.
So like melanin is this thing that like so each. Well, everybody's got it. So like the thing is that like your skin, I think I don't remember the exact number, but I think there's 72 different types, effectively, of types of melanin. Okay. So then you have 3 of them in your body. Okay. So then you take those 72 types and then they start mixing with each other. Does that make sense? like the 70, let's say one of them is like black, 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 dark, 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 right? But then the other one is light, 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 light. So then it starts mixing, okay? And then you would get someone who's more like light skinned or something, okay? So that's all this is. These stupid things that are in our genetics that end up determining this color or whatever, okay? But it's linked to your eye color also. They're related, all right? You can't be like super, super, super dark and have like super light eyes also. That doesn't work out that way. They're not as dark then. They're not as dark then, actually. They're actually literally not as dark. There's a way you can actually see, and you can see they're slightly not as dark, okay? But the thing is the combination of these two things start determining, because the amount of this melanin that's in your skin, it just turns out, well, it doesn't just turn out. This is the way our bodies have developed over billions of years or whatever. But like all animals have this problem when it comes to the sun, and the sun sits here and causes, shoots these rays, and there's radiation that comes in there, right? And then there's different types of ultraviolet light and stuff like that. These different types of ultraviolet light, they react with things that are in your body, okay? So then some of them react poorly, all right? Now, ultraviolet light works on everything. You put this blue paint outside and we leave it outside, the ultraviolet light's gonna start bleaching it. Does that make sense? Over time. Everything gets affected by this stuff. There's nothing that doesn't get affected by this stuff, all right? This is radiation, all right? So this melanin crap that's in your skin, the more of it that you have, the more of that UV, the bad one, actually gets reflected and gets absorbed, okay? So the thing is that the one that doesn't allow that, the person, like his skin, right? Him? No, he can't go hang out in the sun that much. Honestly, he can't. No, he can't survive. No, he can't hang out that much in the sun because you got blue eyes, right? So he's got blue eyes and blonde hair, right? The only combination that's worse than that is blue eyes and red hair. Okay. So the thing is that now, mind you, it doesn't mean that you're actually like completely, in trouble. Some people are in more trouble than others or whatever. Everybody in Ukraine. Everybody in Ukraine. So yeah, so many people. That's why they say the girls are pretty. So this Ukraine knows wins. So but what I'm trying to say though is that the amount that this thing has in your skin, the less that reaction ends up occurring in a negative fashion. Now, don't get me wrong, okay? Just because you're darker black skin, does that mean that you're not going to be affected by this stuff? No, you could still get skin cancer, like definitely, without any question, But the thing is it takes a little longer, and there's a little less chance that ends up happening. But it's not enough that you can sit there and not worry about it. So people still have to go take sunblock and all that. All right, but.
So you tell me drinking green is skin cancer?
Sure. So a particular disease is tested for, and the results are that occurs in 1 in every 425 females and 1 out of 191,000 non-Caucasian people. If 40,000 Caucasian females would be tested, how many of them would you expect to have the disease? What'd you say? How did you get 94? You divide what by what? That's correct. So I'm going to write it out a few ways, okay? So one way is to say that this says one diseased person for every 425 white females, right? Now this is going to be equal to the number of diseased people, and then out of the 40,000 white females. Is that correct? All you do is multiply by 40,000. So then we get 40,000 times 1 over 425 would give you X. If I multiply this side by 40,000, multiply this side by 40,000. But you're right, all you have to do is divide. Does that make sense? Question with this? Does that make sense? Does that make sense? Now, another way you can think about this is the rate at which people have the disease. We're taking the rate and multiplying it times the amount. This is really like a percentage. Is that correct? So all this is percentage of 40,000. Of means multiply. Is that correct? Question? All right. Events involving not or. All right, it says the probability of not E is 1 minus the probability of E. Does that make sense? If so, why? Why is the probability of not E equal to 1 minus the probability of E?
So we're not doing we're not using the E symbol. This.
Not right now.
Oh, we're not doing it?
Not right now.
Oh,
I mean, I can write it that way if you want.
yeah, we're not gonna still trying to figure it out.
Why would this be a true? One is the whole, okay.
Probably at least 5.
Okay, that's true. I just don't like the way you're saying it. Okay, so if you say that there's 11 things, right, and you say 5 of them are like E, and then I should write it this way. Not E is going to be 6, right? The probability of getting E then is 5 out of 11. The probability of getting not E is 6 out of 11. Is that correct? Which is just 1 minus the first one. Is that right? Because it has to be 100% minus the percentage of the first one. Either E happens or E doesn't happen. Is that correct? Does that make sense? So the simplest way to say it is like, if I say the chances that you don't hit the baseball, right? Let's say the chances you do hit the baseball is 30%. Well, the chances you don't hit the baseball then should be 70%. Is that correct? Does that make sense? So this is talking about complement. How do you calculate the probability of a complement? Does that make sense? You guys get it? Justin? When drawing for a 52 card deck, what's the probability that it's not a king? Hmm? 52. 40 out of 52. But that needs to be simplified. That's 12 out of 13. So it's simpler if you just say it's 1 minus the probability of getting a king. That's 1 minus, what's the chances you get a king? 1 out of 13. So then this would end up giving you 12 out of 13. Does that make sense? 1 is the same thing as 13 out of 13. So I take 1 out of 13 away from that, we get 12 out of 13. Is that correct? Again, if you think about it with the columns from before, one of those columns is a king, all the other ones are not kings, so it should be 12 out of 13. Is that correct? When tossing 7 fair coins, what's the probability of getting at least to 1 heads? All right, this one's harder. At least 1 heads. We haven't even talked about really how to calculate this when we start talking about like getting 2 heads, getting 3 heads, getting 4 heads, getting 5 heads, getting 6 heads. So this would really mean the probability of getting 1 or 2 or 3 or 4 or 7 heads. Does that make sense? Does that make sense? That's kind of hard, because I would have to calculate each one of these things individually. In other words, it's like 7 different problems. Do you understand? They don't want you to do it that way. They want you to think about the complement. What's the complement of at least 1 heads? Sorry? Nope. If I say, what is not at least 1 heads? What does that mean? If I say you got at least 1 heads, you're like, no, I didn't. Then what happened? You got no heads, right? So the thing is at least 1 heads is like X is greater than or equal to 1. Is that correct? If X is the number of heads. So the probability of at least 1 heads is actually equal to 1 minus the probability of the complement of at least 1 heads. But the complement of this is just to say 0 heads. Is that right? Does that make sense? 0 heads is a lot simpler than sitting here and saying 1 or 2 or 3 or 4 or 5 or 6 or 7. Is that correct? All right. How am I going to calculate that? How am I going to calculate the probability of getting 0 heads?
Depends if we have any money. Yeah.
Sorry? You need to think about the total is correct. So what's the total number of ways that we could flip 2 coins or flip a coin 7 times? Way more than 14.
You said 1 out of 14?
Sorry? 128 is correct. How'd you get 128? 7 times. That's correct. Very good. So the first one is the first coin you can get a heads or a tails. Is that correct? The second coin you would be able to get a heads or a tails, right? Is that right? The third coin, then you would be able to get a heads or a tails. Is that right? And then we would have to do this for 7 coins. Is that correct? Each time you see it's branching 2 times. Is that right? So how many ways could these coins happen? 4, 5, 6, 7. The first one has 2 choices. Next one has 2 choices. Next one has 2 choices. Next one has 2 choices, 2 choices, 2 choices, 2 choices. It's 2 to the power of 7. That's 128. There's 128 ways that we could flip a coin 7 times. There's 128 different outcomes we can get if you flip the coin 7 times. Does that make sense? One of those will be all tails. Is that right? Is that right? Right, you have to go down this side over here. Is that correct? So you put 1 here. In other words, this is going to be 127 over 128. Also, if I say you flipped a coin 7 times, should it be 13 out of 14? The chances we get at least 1? I mean, it should be really easy to get at least 1 heads if we flip a coin 7 times. Is that correct? Right? So this is saying it should be 127 over 128. Does that make sense? Question with this? This one's hard though. The point of this example is if you have to start doing something where there's a lot of things to add up, and we talked about this in the other section also, it was D4, I think. All right. Every single time they start saying at least, that's a bunch of events. Does that make sense? They always want you to think about the complement. The complement will somehow be simpler. It's much easier to sit here and say how to get 0 than it is to say 1, 2, 3, 4, 5, 6, or 7. Does that make sense? You get what I'm saying here? All right. This is difficult, but at the same time, there are things in the question that can tell you to do it. Does that make sense? So when they start talking about a bunch of events, try and think about the complement. Try and always think about the complement. Ask yourself which one's easier. Does that make sense? Complement's easier to the complement, right? All right, this rule. I feel like we've seen this before multiple times. Is that correct? Haven't we seen this before? Because we wrote it this way before. We said the number of elements in A union B is equal to the number of stuff in A plus the number of stuff in B minus the number of stuff that's in A and B, because you're counting them twice. Is that correct? If I take this thing and I divide all of these things by the number of elements in the sample space, the number of elements in A union B divided by the number of elements in S is the probability. The number of elements in A divided by the number of elements in S is the probability of A. This is the probability of B. This is the probability of A and B. So it's kind of the same thing we talked about before. If you have A here and B there, if I count up all this stuff, and then I count up all this stuff, I count the stuff in the center twice. Is that correct? So you have to subtract it once. Does that make sense? Now, a lot of times, you don't even need to use the formula. All right? Sometimes you do though. So we have to remember it. Okay? Sometimes, most of the time it's easier not even doing it. Just always the first thing you should try to do when you do these questions is number divided by total. Try and think about what the total is. Try and think about the number of favorable. Does that make sense? If you can do that, you're done. You don't have to do any of this crap, right? All right, if 5 fair coins are tossed, what is the probability of getting at least 2 heads? All right, now a little more difficult, okay? This is the probability of getting 2 or 3 or 4 or 5. Is that correct? Or we can think of this as 1 minus the probability of what? Sorry? First, I want to know what the probability should be here. If I write a complement of this, what needs to go in here? What's the complement of this event? What's the complement of at least 2 heads? Sorry? That's correct. So it's either 0 or 1. Does that make sense? Does that make sense, guys? Right? If you flip a coin 5 times, you're either going to get 0, 1, 2, 3, 4, or 5 heads. Is that right? So if they start asking me for the chances that we get 2, 3, 4, or 5, right? If I'm able to figure out these chances here, all I do is add that stuff up and just say 1 minus that. Does that make sense? You get it? Simone? Tired? You okay? All right, so then this thing, 1 minus the probability of 0 or 1. Does everybody see that? All right, well, let's calculate the probability of 0 and the probability of 1 separately first. If we can figure those out, all we do is subtract. Does that make sense? All right, which one's easier, 0 or 1? 0, I think, is easier. Does that make sense? How would we calculate the probability of getting 0? In other words, 0 heads means all tails, right? So that means we gotta get 5 tails. That's the same thing as just saying 5 tails. Is that correct? How do we do that? Total is correct. Oh no, I didn't say why, I said how. Sorry. What's the total in this case? 32 is correct. There's 5 different things. There's 2 choices for each one, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Does that make sense? Does that make sense, guys? Right? To the power 5, same thing. Right? Now, what's the, so what do I put in the numerator? There's a 100% chance you get 5 tails. 1. There's only one way that's favorable that you can get 5 tails. You have to get 5 tail on all of them. Is that correct? There's not multiple ways you can get 5 tails. Is that right? You understand? Does that make sense? Everybody okay with that part? All right, so believe it or not, part of that was fairly easy. Well, let's write this also. So this is the probability of getting 0 plus the probability of getting 1. The reason why I'm allowed to say that is you cannot get 1 and 0 at the same time. Does that make sense? You flip 5 coins, either you get 1 heads or you get 0 heads. You cannot get 0 and 1 at the same time. Is that correct? So this portion here is 0. So in other words, the probability that you get 0 or 1 is really just equal to the probability you get 0 plus the probability you get 1. We figured this part out now. Does that make sense? So the only thing we have to do now is figure out that part. Does that make sense? Yep. Now, to get the 1 here, it's very similar to the previous calculation, but there's some part that's a little different. What is different here? Say again? This is going to be, you're right, this is going to be 4 tails, 1 heads now, right? Right? The denominator is still 32. There's still 32 ways any of this crap can happen. Is that correct? Right? Now we have to say the number of ways that we could get 1 heads. Is that correct? We flip a coin 5 times. Number of ways we can get 1 heads. What would we say? What'd you say? 5 is correct. Why do you say 5? Yep. There's like 5 slots here. Very good also. There's 5 slots here, right? If I get heads here and then tails, 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 right? I mean, we didn't have to get a heads on the first one. Is that right? So it could be tails, heads, tails, tails, tails. Could be tails, tails, heads, tails, tails. Is that right? Or you can get tails here, or you can get tails there. Or heads there, excuse me. There's 5 different ways. Is that correct? You could also say this is 5, choose 1. Does that make sense? There's 5 of them. I need to pick groups of 1 to give it a heads. Is that right? What's 5C1? Well, that's 5 factorial over 4 factorial, 1 factorial. That's 5 times 4 factorial over 4 factorial times 1. So we get 5. Does that make sense? So this is 5 out of 32. Does everybody see that? In other words, this is 1 minus 1 out of 32 plus 5 out of 32. Does that make sense? So then we get 1 minus 6 out of 32. 6 out of 32 can be simplified though. We might as well do that. So we might as well make the number smaller. Does that make sense? What's 1 minus 3/16? If you have to use your calculator, you're going to fail this stuff. You're not going to be able to do it. You're not going to be able to do the questions. I'm just telling you, because if you don't understand what the fractions mean, you cannot understand the formulas. And you have to understand complement. That's correct. If there's 3 out of 16 that are favorable, right? This is just the complement. Is that correct? 1 minus. Does that make sense? 1 minus whatever is the complement, right? So if there's 3 out of 16 here, there's 13 things that we haven't counted. Is that right? This is the same thing as saying 16 over 16 minus 3 over 16. Is that right? Which is 16 minus 3 over 16 or 13 over 16. Does that make sense? So all I'm saying is that if you just think about a complement and you just start telling me there's 16 total things here, right? And we just got 3 of them, right? There's got to be 13 things left over here. Is that correct? 16 minus 3. Is that right? No, but if we don't understand how to do 1 minus the thing, you're not gonna understand what complement, or how to calculate the probability when it's a complement. Does that make sense? Because that's what the formula really means, right? I would definitely check it on my calculator. But if you don't understand, if you don't write it out and understand it without doing it on a calculator, I don't find that the person at the end, when they get the final answer, they can understand whether they're getting the right answer or the wrong answer. Does that make sense? All right. So then that means when you're taking a test and you do something on the calculator, and then it spits out a number, and you pretty much have to write that down. And I don't know if the person can tell me if it's right or wrong at that point. Does that make sense? All right. If one number is selected from the random set, blah, 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 find the probability of the following number of events. The number is odd or a multiple of 4. The number is odd or a multiple of 3. All right. How would we do the first one? I'm going to do this question. No, actually, you do this one. Tell me what it is. This one's easy. How would I do the number probability that the number is odd or a multiple of 4? How do you get 1/2? Shouldn't get 1/2. 7 out of 10? 5. That's right. So odds, right? This is odd, 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 right? Multiples of 4 are those. Is that correct? Sorry? 4 is not, one's not a multiple of 4. Because like multiples of 4 means like 0, 0 plus 4, 4 plus 4. Does that make sense? Right? Whenever you like, so like if you multiply by 1, you multiply by 2, you multiply by 3, but 4s. Does that make sense? So then this is, but what I want you to do with all these questions is always try and do the number over total thing first. Does that make sense? So in this case, total for sure is 10, no question. Is that right? So if they say odd or a multiple of 4, right? Identify the ones that are odds or multiples of 4. Is that correct? You can just literally start doing them one by one. Is this odd or a multiple of 4? Yeah, it is. Is this odd or a multiple of 4? No, it's not. Is this odd or a multiple of 4? Yeah, it is. This one is. This one is. Is that correct? So we would get 7 of them. Is that right? Does that make sense? Or we can use the formula. The probability of odd, or a multiple of 4 is equal to the probability of odd plus the probability of a multiple of 4 minus the probability that you're both odd and a multiple of 4. Does that make sense? What's the probability you're odd? 5 out of 10. I've already identified all the odd numbers, right? What's the probability you're a multiple of 4? 2 out of 10. What's the probability you're both odd and a multiple of 4? And what's the answer? Sorry? What's the probability you're both odd and a multiple of 4? 0, that's impossible. You can't be odd and a multiple of 4 at the same time. Is that correct? How many of the numbers in this list are both odd and a multiple of 4? None of them. Right? That's impossible. Does that make sense? So then you get 5 plus 2 minus 0, so you get 7 out of 10. We better get the same damn answer, otherwise this formula sucks. Does that make sense? Right? You see what I mean? Like this one here, I'm just writing it out just based off definition. Does that make sense? I'm just saying, what's the total? And I'm counting how many are favorable. There's only 10 things in the first place. We can look through the damn list and see how many of them are favorable. Is that right? Does that make sense? You guys understand? All right. Let's do this one here. What's the probability now that it's odd or a multiple of 3? What would you say? 8 out of 10, you say? No. Odd or a multiple of 3? Six out of 10 is correct. How'd you get 6 out of 10? Well, this one is a multiple of 3, this one is a multiple of 3, and this one is a multiple. But you already counted 3 and 9. You can't count them twice, right? What's the chances your name is Simone? Oh, 1, 2, 3. That'd be a couple. Does that make sense? You understand what I'm saying? No, but that's the whole point of this formula, right? That you don't want to double count the things you've already counted. Does that make sense? That's all this is about. That's all this formula does. All right. So the answer should be this. Does it make sense why this is the answer? You just count them directly, right? All right, let's use the formula now. This is 3 out of 5. Now let's do the probability of getting odd or a multiple of 3. That has to equal to the probability that you're odd plus the probability you're a multiple of 3 minus the probability you're both odd and a multiple of 3. What's the chances you're odd? 5. That's not a chance. 5 out of, yeah, just be careful with that. Does that make sense? Because that's what they're going to put on the test. All right. You can't just tell me, if I say probability, you can't tell me 5. Right. So this is 5 out of 10. What's the probability you're a multiple of 3? 3. There's 3 of them, right? Yes? 3 out of 10, right? Why'd you say 2? Okay. As long as you understand, that's all that matters. All right, so this is 10 here. What's the chances you're both odd and a multiple of 3? What'd you say? No. No. What is it? Look at the stupid list. How many numbers in that dumb list are both odd and a multiple of 3 and 9? Does that make sense? Because that's why I'm circling these things. Is that right? Just identify them. Does that make sense? Where are they overlapping? The set's overlapping. What's in common to both of them? Is that correct? And means intersection. Is that right? Does that make sense, guys? Any question with this? All right. Hopefully now we get the same answer we just did. Otherwise I did something wrong. So we get 5 plus 3 is 8 minus 2 is 6. Good. We get the same damn answer. So that's probably correct. Does that make sense? All right. We'll do this last one and then we'll stop. I feel like people want to go. Maybe we should do the next one too. No, I'll do one more. We can leave this. All right. If a single card is drawn, 52 on our deck, what's probably there'll be a spade or a red card. This one's easy, actually. No, we gotta do both these, actually. Say one time. 30 over 52 you got? No. It's not, 30 is not correct. Sorry? 26 out of 52 for what? 26 is for the red, that's correct. No. 39 is correct. Okay. So the probability that you end up getting a spade or a red card is going to be 39 out of 52. Because how many spades are there? There's 13 spades. How many red cards are there? 26. So then we end up getting 39 out of 52. Turns out 13 goes into both of these things. We get 3 out of 4. Now, again, though, you should have really been thinking about this just in terms of suits. There's diamonds, clubs, hearts, and spades. Is that correct? There's 2 red ones, right? And then we're picking one of the black ones. Is that right? It's 3 out of 4. Does that make sense? Does that make sense? You get it? Akamiri?
No, I just don't even know it.
There's diamonds, clubs, hearts, and spades. 2 black suits and there's 2 red suits. There's 2 black suits and there's 2 red suits. So 3 out of 4. Does that make sense? You get it? Find the probability that a single card is drawn from a 52 card deck will be a diamond. This is supposed to be or. Or a face card. So they want to know what's the chances that we get a diamond or a face card. So I'm just going to write this as D or F. Does that make sense? What do you mean? You gotta be careful. Gotta be careful. It should be 3 out of 52. Because it's Jack, Queen, King. Does that make sense? Of diamonds. If I said, what's the chances that we had a Jack that's also a diamond, right? Then it would be 1 out of 52. Does that make sense? All right. What's the probability we get a diamond or a face card? What'd you say? 25? No. Making the same mistake you just made before. Aren't some of those diamonds face cards? So why don't you count the diamonds and then count the face cards you haven't already counted? How do you get 22? How do you get 21? Subtract 3 and then add 12 is correct. So 9 plus 13, is that right? So there's 13 diamonds. Does that make sense? Then there's 3 face cards in each suit. Is that right? Jack, Queen, King. Is that correct? So if I count all the other suits and don't count the diamonds, there should be 9 more that I should add. Therefore, we get 22 out of 52, which is the same thing as 11 out of 26 if we divide by 2 here. Does that make sense? Now, again, though, you can just use the formula if you want. Diamonds or face cards is diamonds. It's face cards minus diamonds and face cards. What's the chances you get a diamond? 13 out of 52. Stop saying 13 though. Say the denominator. All right, because I'm telling you, you're gonna get it wrong when you do it. 13 out of 52. What's the chances that you get a face card? There's 3 in each set, right? There's 4 sets, so 12 out of 52 is correct. What's the chances that you get a diamond and a face card? 3. There's 3 diamonds that are face cards. Is that correct? Jack, Queen, and King. So this is 3 out of 52. In other words, the answer is 13 plus 12 minus 3 out of 52. Or 25 minus 3 is 22 out of 52. So we get the same answer. Does that make sense? Let me see if I have the deck still copied here. I do. Diamonds, yikes, where'd it go? Diamonds or face cards, right? Right? Now, we did this before. Same question. They're just asking us a probability now, so all they wanted was now divide by 52. But diamonds and then face cards are over there. Is that correct? Right? So if you do 13 plus 12, you're counting these 3 twice. Is that correct? So the stupid formula says 13 out of 52 plus 12 out of 52 minus 3 out of 52. It's like, oh, you just counted these twice. Subtract them. Does that make sense? Question? You just think of a number in the side of each one and divide by that number on the top and the bottom. Well, you could you pick any number that goes into both of them. It doesn't matter. And then just keep doing it until you can't do it anymore. All right. But like, let's say you have 12 out of 18. Okay. Fine. 6 goes into both of them. If I divide by 6 over 6, you would get what? 2 over 3. Is that correct? People call this canceling. Cancel this with 6, you get 2. Cancel this with 6, you get 3. Is that right? But maybe I don't see that the 6 goes in there. No big deal. Do whatever you do see that goes in there. Does that make sense? I mean, for sure, I see 2. I know everybody knows it's even. So this is 6, and this is 9. Is that right? This has to be equal 6 over 9. Is that correct? Then I just keep asking yourself the same question. Does anything go in there again? 3 now goes in there, right? So then 3 goes in this one twice. 3 goes into this one 3 times. So we get 2 out of 3. So effectively, all I did was I divided by 3, and then I divided by, or excuse me, I divided by 2, then I divided by 3. But dividing by 2 and then divided by 3 is the same thing as divided by 6. So it doesn't matter. We don't see the biggest number that goes in there. Just make it smaller. Then when it gets smaller, then it gets easier to see what the other number is anyway. Does that make sense? Okay, you just got to keep doing it. All right. Question? All right, so we'll stop there. We'll do a couple more of these next time, I guess. All right. What'd you say? That's what you say. I wouldn't go that far.